Good morning. We are going to do another section of Chapter 8, Physical Science. So this is for North Montauk High School students who are taking Physical Science under Miss Wells. So we're going to move on and do Section 3 today. If you watch Section 1, we're skipping Section 2. So we're moving on into Section 3. So let me get that loaded and started. All right, so you should see your notes coming up. Always reference back to your packet. These are the exact same notes that are in your packet, so you can read them and follow along at the same time as we are. Okay, so Section 3 is called Changes in State. So we're going to look now, after we've already covered the main states of matter, we're going to look and see how they can change from one to another. In the first section, we did include plasma, and we will not be including that in this section of changes of state. So we're just going to look and see how things can go from a solid to a liquid, for example, or a liquid to a solid. And you can study this little diagram, and that'll help you understand it better. So basically, when a solid changes into a liquid, you already know that that's melting. And the amount of energy needed to change a material from a solid to a liquid is called the heat of fusion of that material. And you do need to know when this happens that it absorbs or takes in energy. So it needs energy for this to happen. When matter changes from liquid to solid, freezing occurs, and this releases energy. So that's kind of the only confusing thing, is knowing if it absorbs energy or releases. Vaporization occurs when you boil water. So in boiling, you add enough heat to a liquid until it reaches a temperature that it changes to bubbles of gas below its surface. And once again, in this instance, energy is absorbed. So you can look at the picture and watch the boiling of water. The boiling of a liquid is the temperature at which the pressure of the vapor in the liquid is equal to the external pressure acting on the surface of the liquid. This external pressure is a force pushing down on the liquid, keeping the particles from escaping. Particles require energy to overcome this force. Heat of vaporization is the amount of energy required for the liquid at its boiling point to turn into a gas. In evaporation, a liquid also changes to a gas, but now it's going to be gradually, and it's going to be at temperatures below the boiling point. So that's the difference between vaporization and evaporation. You can use the kinetic theory that we've already studied to explain how water evaporates from your skin and how it cools you. When a liquid evaporates, the particles do not all have the same kinetic energy. Many fast-moving particles will sort of break away from the rest of the liquid, and that causes them to turn into a gas. As these fast-moving particles leave, the average kinetic energy of the remaining particles that are still left becomes less. As a result, the temperature of the remaining water then goes down. Because the water is now cooler than your skin, it takes heat away from your skin and cools you off. So when you sweat in the summer, that's why it's a method of cooling you off. So you can see the difference. These are both going from a liquid to a gas, both these pictures, but you can see the difference in boiling and evaporation. A different change of state that's not talked about as much is called sublimation. And this is when we go directly from a solid to a gas without going through the liquid state. So usually we would go from a solid, then to a liquid, then to a gas. Then in this example, it goes straight from a solid to a gas, and this does absorb energy. So you see in this picture, kind of see the fog or the smoke around it. It's not smoke. It is water vapor, and this is going straight from a solid to this gas form. Once again, my videos will not play in this presentation. And then we have condensation, and this is going to be opposite. It's going to be when we go from a gas to a liquid. And now, instead of energy being absorbed, it's released. Condensed water often forms when warm water containing water vapor comes into contact with a cold surface, such as a glass of ice, or ground that has cooled during the night. I know when I was little, I used to think that somehow when you had a cold glass of tea and it had water droplets on the outside, I thought somehow that the water went from inside the glass through the glass. But what's happening is that cold glass is just cooling the air around the glass, which causes the water to condense out. Condensation also occurs in the atmosphere when warm air rises, cools, and loses its capacity to hold water vapor. All right, and that ends our lesson on how things go from one state to another. So we'll stop this video. And I have just a few more videos left to do on this lesson that will get finished up, and that will take care of chapter 8.